Okay, guys, let's get started. And welcome to AI Tech Labs. And it's a introductory course and tell you how to teach you how to use our HPRC clusters and run your jobs on our clusters, like AI machine learning frameworks on our clusters. And you can see my name. My name is Zhenhua He, and I'm a staff member at Tamil HPRC. This is my email, and you're welcome to. Actually, we have a help desk email as well. You can send your questions. I will show you the email later. And if you send a help desk email, more people will see the questions, and then more people can help on the questions. Okay, let's get started. Should I put it here? Okay. The AI Tech Lab short course is composed of 4 different lab sessions. You can see the first lab session is called a Jupyter Lab. In this lab session, I will teach you how to create a virtual environment on our cluster. And then we will be using our HPRC Open On Demand portal, which is a web portal that you can utilize our HPRC clusters. So I will teach you how to run a Jupyter Lab on the HPRC Terra portal. Today, maybe some of you guys have heard about our Grace cluster. It's under maintenance today, so we decided to use the Terra cluster today. So the second lab is called data exploration. We will go through some examples with the 2 popular Python libraries called Pandas and Matplotlib for data exploration. So the Pandas is used for data manipulation and analysis. So you can, it has 2 data structures, and you can, for example, one of its data structure is called data frame. You can use you can save your data into a data frame, and then you can do some manipulation, like you want to drop some columns, or you want to add some columns, you want to do some like sorting, filtering, or other operations. You can use Pandas to do it. Matplotlib is a Python library for plotting. So we can do like some scatter plotting, like with markers, and we can do lines plotting with the different line styles. And we can also do subplots, color plots, and also 3D plots. So we will talk about these in the second lab. The third lab is about machine learning. So in this lab, I will teach you how to use the machine learning library called scikit-learn for to solve some linear regression problems, classification, and clustering problems. So this is our third lab. And the fourth lab is called deep learning. We will learn how to use Keras to create and train a simple image classifier to identify some handwritten digits with the deep neural networks. So this is about our 4 lab sessions. I will, for each lab after lecturing for each lab session, I will open several breakout rooms. I'm not sure how many students are there now, both in classroom, and I think we have about 24 students on Zoom, and then we have some students. So I will do create several breakout rooms, so you guys can work in groups, and we encourage you guys to communicate and discuss about some examples in the Jupyter notebooks. Okay, let's continue. This is the, not sure if this is a good place because my video is blocking something. Oh, looks fine on the Zoom. Okay, great. Because I try to keep moving it to side by side, but now okay. Since it's good on Zoom, I don't worry about it. So this is the Jupyter Lab. And you can see actually this is the interface of the Jupyter Lab. So you can see it's a modular structure. And on the top, it's a menu bar. You can click File, Edit, View, Run. And also you can run the cell code cells and text cells in your Jupyter Notebook. Here on the left side panel, it's kind of a file browser. So you can see we have some files here. So if you double click any file, it will open a tab in the main working area. So you can try to like code into the Jupyter Notebook. For example, in here, clearly you can see two different cells. This cell is called a content cell or a text cell. You can write some documentation for your code. And also this one is called a code cell. So you can run some code. You can run code by click the, first you need to highlight the code cell you want to run, and then you click the run button. Or you can use Shift Enter. When you highlight the cell, you use Shift Enter to run the cell. That's a second way. So this is about the Jupyter Lab. And here I want you to show you guys some HPLC resources. And so to get you guys more familiar about our resources. Some of you guys may be new to our HPLC resources. So the first one is our web page. If I click it, so you can see some quick links here, and you can apply for accounts. I know some of you guys may forgot to apply for account with us, so I strongly encourage you to do so if you want to use our resources. And also we have like a user consulting training. In this training session, we have short courses listed, so you can see about what short courses are coming up. And also software, what softwares we have on our clusters, frequently asked questions. And also we have a user guide for our clusters. This is for our Terra cluster, and this is for the Greece cluster. And also our today we are gonna use Portal which is a web portal. We are gonna run Jupyter Lab on the Terra portal, and this is the Galaxy. So you can look at it as well. So on this page, you can also check the cluster status, and you can see how many nodes we have on this cluster. You can see actually no jobs are running on Greece today. So because it's under maintenance, so and also you can see our Terra cluster. We have how many nodes are active, how many cores are active, and also how many jobs. We have about 343 jobs running on our Terra cluster now, and we have about 105 jobs in queue. So get back to here. If you want to use the Terra cluster, you have a quick start guide. So on this quick start guide, it's very useful. It tells you how to access the Terra cluster. If you are off campus, please do log onto VPN so you can use our clusters. and also navigating the Terra, like your home directory, Scratch directory, and about your storage quotas, and how to transfer files, and all these, and how to use module command to find a software. If you want to use some software, you need to use some on our cluster, you can use module commands to find the software. And also we have some job file examples. If you want to do submit the batch job, you need to have a job file. And we have examples about these job files and submitting jobs. So this is about the Terra Quick Start guide, and we also have HPRC portal. So this is our open on demand portal. We have it for Terra cluster and Greece cluster. So if you click Terra on demand portal, you will be landing on this page, and it has some tabs. The first one says file. Actually tells you about the you can navigate to your home directory and Scratch directory. So if you have files, you can upload and download files, use these files tab. And also these jobs, for example, you have some jobs submitted to our clusters, you can check the status here. And also we have a cluster tab, and it will allow you to access our Terra shell. And shortly, we will be using this Terra shell to create our virtual environment with some commands. We also have a lot interactive apps here. We have some bio apps, GUI, imaging, and also servers. Today, we are going to use the Jupyter Lab. I will show you shortly. And also a dashboard. The dashboard will, okay. The screen is still good. Okay, I thought. So we have a dashboard. You can use the dashboard to check your SUs, the service unit. Because when you run jobs, this will consume your service units, and you want to look at how many SUs you have used and how many SUs you still have. So, and also if you are not like you don't have enough like a file count, file limits, or like space in the directory, you can send a request to us by using this dashboard as well. We have a dashboard text box there. You can write your justification why you want to use so much space and so many file counts. You can let us know, and we will have some staff members to review it and probably approve it. So, and also this is my interactive sessions. For example, if you run interactive apps, for example, Jupyter Lab, your interactive sessions will be shown here. So we also have a HPRC YouTube channel. It's very useful for new users. For example, you can see we have 400 something subscribers now. And these videos, some are very short, some are very, some are like 1 hour or 2 hours, and it'll give you some, for example, if I can find, okay, this one tells you how to use our open on demand portal, how to use the web portal, the Terra portal or Greece portal. It's very useful. And also, introduction file transfer, use a Globus connection. And also we have some courses here, introduction to Python. And also we have some other courses that you might be interested in. For example, if you want to use some softwares on our cluster, you can use the module system, module load or module spider to find some software, and you can use module load to load the software into your directory, so you can use it. So this is Jupyter project is about for today's first lab 1, we'll be using Jupyter Lab. So this is a link to give you an introduction or about what is Jupyter Lab, and also help. So let's get started. For today's short course recording, we will need some time to process it, and so I'm not sure when it will be on YouTube channel. So so I will maybe about 1 week or 2 weeks post processing. So we will post it on our YouTube channel. Okay. And so this is about the login HPRC portal. So you can see we have 2 open on demand portal. If you are interested, you can even look at the user guide. So let's go back to the portal. So are you guys on this dashboard, Tamil HPRC on demand Terra portal? If you are not, don't worry about it, and I will give you some time, like after my lecture, I'll give you like 15 minutes. I will break you guys into several groups, so you guys can learn and study and together and in groups. So next I will be using clusters tab, and then click Terra shell access. It asks your password. I type my password to the shell, and then after you enter your password, it asks do 2-factor login for this should be your net ID, and then you have 3 options: do push it to your phone number, phone call to your number, or show a message, a passcode to your phone number. But I choose to be 1, so it will send me a push notification. We're using Terra, right? Yes, we are using Terra. So you can see on the URL it says portal Terra. So yes, we are using Terra. And then now I'm on the, if you want to see this, I want to PWD, so you can see I'm on the home directory. So let's see what to do next. So we have gone through these steps. We have logging to our Terra cluster. And then the next step is to create a virtual environment. So these are all the commands you need to create a virtual environment on Terra cluster. A virtual environment, you create a virtual environment and you install for example, the libraries you need into the virtual environment, so you can run your jobs in the virtual environment. And also, virtual environment is isolated, so you have one version of, for example, package in this virtual environment. It won't affect your packages in another virtual environment. So that's a good thing. And so the first command is called cd scratch. So this will change your current directory to your scratch directory, because we have more space and file limits in the scratch directory. So that's why we want you to work in your scratch directory. Module purge to clean the command is to clean up some existing modules you may not use. So, and then for today's virtual environment, we want to use Anaconda. This version Anaconda, we will use some Conda commands to create the virtual environment. So, and then we use Conda create command -n, like you can also use --name, and you can give it a virtual environment name, and then you can use the source activity this is your virtual environment name. You can activate the virtual environment. And these are the libraries, JubraLab, Pandas, Matplotlib, Scikit-learn, TensorFlow that we'll be using today. So we need to install all these packages into our virtual environment. Deactivate the virtual environment when you do not use it. If you use it, you can't keep it active. So this is the basically kind of like a flow chart for create virtual environment. So I will give you guys some time to do this. And also before sending you guys to a breakout room, I will talk a little bit more. So we have some common Anaconda commands here, and you can show the Conda installation. For example, you can do conda info --imps. It will show you what virtual environment have you installed, and then you can use the conda create. We just use it to create a virtual environment, and you can of course you can use a specific Python version to create a virtual environment. And this also did the same thing with the conda inf --imps. So it will give you a list of the virtual environments. Conda list all the packages, search a package, install the package, update the package, and remove package. So you can practice these Anaconda commands after class. Maybe for some of them will not be used in the first lab. So hopefully you will find some of them are useful after this short course. So this is the GitHub repo. You will do a git clone command to clone a copy of the Jupyter notebooks to your directory. So we will run these Jupyter notebooks on our Terra portal in the Jupyter lab. So you can simply like copy and paste these like green commands into your terminal. And so next, we will go to our Terra shell. So you will be, it's better if you have two screens. For example, you open these presentation slides and you have another screen that has this Terra shell, and you can type the command, either copy and paste the command or type the command into the terminal, and you will be, hopefully you can successfully create the virtual environment. So let me check how many students we have. We have about we have about 20 students, so I plan to create 4 breakout rooms. So we have 5 students in each breakout room. So we also have some teaching assistant. So we will also be stay in breakout rooms, so you can get help from them as well. So let me create a breakout room. Okay. Give me maybe 2 or 3 minutes. So check out the breakout rooms. Create 4 breakout rooms. I will assign manually. Okay, I'm gonna have 1, 2, 3, 4, 5. And in the second breakout room, 1, 2, 3, 4. Oh, and in the third breakout room, I think we can just use 3 breakout rooms. I will open the breakout rooms now. So please accept the invite and work in the breakout rooms so you can use the kind of commands to create your virtual environment. Open the breakout rooms now. Did you receive an invite? Okay, great.
So we have to go through the steps that you had said in this, right?
Yes. Yeah. You follow that command to create the virtual environment.
Okay, let's continue. And the next lab is about, hopefully you guys have created a virtual environment. If you have questions, problems, and you can send us an email to helpdesk@hprc.tmu.edu. We can help you with that. And also, you're very welcome to contact us. So the next lab session is about data exploration. So in this session, we'll be talking about two lab sessions, the 2 Python libraries. The first one is called Pandas. It's a Python library for data manipulation and analysis. So it has 2 main data structures. One is called a series and the other is called data frame. So we can do either some operations on the data structures. The matplotlib is a Python plotting library, so we can create a different type of plot using matplotlib. So you may be working on a data science problem. So actually, we have different types of data science problems. For example, we can have some descriptive, it's just the summary of the data, the set of data, and also maybe have some exploratory to search some unknown, and also inferential, find correlations between the measurements, and also some predictive data science problems seek to make predictions. Some causal data science problem is seeking to explore causation between measurements. So here is a smoke versus lung cancer, and the mechanistic determining the governing principles. For example, you change one measurement it will lead to the change of another, for example, exclusive change of another measurement. So kind of determining the governing principles. Here we have a tree structure, and if you think about your problem and you choose down, and if you aim at some node, aim at some leaf, so that will be your type of a data science problem. So this is from a book called Elements of Data Analytical Style. So you are very welcome to check out this book, and we also have some more examples about data science problems, so you can learn about it. So as I said, Pandas has two data structures, and the first one is called a series. It's a 1D labeled array of data. So you have an array of data, and also you have labels. These labels called index. So so-called index. I will show you shortly on the next slide. Data frame is a Pandas data structure. It's 2D labeled, also labeled, and the size mutable, meaning that you can change the size of the data structure. For example, you can drop rows, you can add rows. So you can change the size of the data frame. And tabular data structure, it means like you can view it as a table. You can also think of it as ordered collection of columns. So, and it's a homogeneous type. Each column can have a different data type. So series is capable of holding any data type. It can be integers, strings, or floating point numbers. So for here, I give an example. For example, you have some stock price data, like we wanted the stock price data to be our value and the index to be the date time type. For example, it's date time type. So you can access the value by using the date time. So this is how it works. And this is the default index is from 0, starting from 0, 1, 2, 3, 4. You can, of course, you can use the custom index. You can set it as A, B, C, D, E, or something else. So data frame is a primary Pandas data structure. So here it also says it's a dict-like container for serious objects. Why it says that? Because if you know about the Python dictionary structure, data structure, it's about a k-value pairs. So for here, actually, the data frame is like the column labels is kind of like the k, and this series object is the value. So it's also k-value pairs. So it's kind of a dict-like container for series objects. We have talked about the two-dimensional size mutable and heterogeneous. Here I give you a CSV file. It's from a house marketing it's a house SEO marketing CSV file. So you can see we have different columns, and we can read this CSV file into data frame, and we have ordered like collection of columns. So this is, and you can see we can have in each column we can have a different data type. We have a Boolean type, floating point, and a string in the integers. So for Pandas in this lesson, you will learn how to create a data frame, drop entries, index, select, and filtering data, sorting data, and also you will learn how to like read a file into a data frame and also write a data frame into a file. Let's go to the Jupyter Lab exercises. Let me first start my Jupyter Lab. And this is our module and content module and optional environment. The virtual environment we just created. And the number of hours I set it to be 3. Number of cores to be 1. And I want to use 2 GB in memory because I don't want to use too much. And node, I just choose any. If you can choose GPU, but GPU node is busy, so sometimes you will need a longer time. So I will just choose any. So I will click. I don't want to receive an email, though. If you want to receive an email, you can check, type your email, and then I will launch. Uh-oh. Let me open it again. Just a terror demand. Jupyter Lab. I think these are all filled. I click launch. Why? Should I just let me try again. Yes, now it works. If that session was successfully created, and then we will need to wait 1 or 2 more minutes to have the, after 1 or 2 more minutes, we will have a blue button here saying connected to Jupyter Lab. So we will be able to work on the Jupyter Lab. It takes maybe 2 minutes, I think. So we will leave it here and go to, so here I give a Pandas cheat sheet. So if you are interested in doing more operations, you can look at this Pandas cheat sheet. And of course, sometimes you don't need them now, but in the future, you may need it. So and also let me go back. Okay, now we have the blue button showing up now. It says connect to Jupyter Lab, and also you can see on this session you have a host. So actually your job will be landing on this compute node. So, and also you have a creation time. It tells you when this job was created and then time remaining. I just created this session, so I still have about 3 hours. And the session ID, you can click the session ID maybe, and we have some output log. It tells you some more currently loaded modules and packages. So it'll tell you some information about this session. So if I click to Jupyter Lab, so that's because I do GitHub, Git clone, and then I have this AI labs in my Scratch directory, and along with some other folders. Okay, please, I know some students have stuck on session, so it may take a few more minutes. So please be patient, and I will just briefly give you some walkthrough about what this Jupyter notebook about, and then after that you can work on look at the examples, and then you can even write your code. Oh, so I think for Ethan, your session may have expired because so you'd better to reopen a Jupyter Lab session. So you can reopen it to give it a little bit more time. For example, 2 hours from now. I think 2 hours is enough by now. So this is our data exploration. We have talked about this. And first, we need to import the libraries we need. So here I use the pandas and NumPy. If you, I'm gonna first restart my kernel. I will maybe want to clear all the outputs, so make it a little mystery. So you can see here, I need to import my pandas, and also because we want to work on series and the data frame, I also import the series and the data frame. If you don't want to do that, you can do pandas.series or pandas.dataframe. That's also okay. And also I use NumPy. Maybe I use some NumPy array somewhere. So you can highlight, click in the cell and then highlight it, and then you can either click the run button or use Shift Enter. 2 ways to run the code cell. So now this code cell has been executed. So let's go to create a series. Here, I give an example about creating a series with a Python list. So you can see we have a Python list. And then this series will convert this Python list to a series. So, and this series will output what the series look like. It's called a servant. Let's run this cell. So now you can see we have the labels, the index, and also we have the values. So this is how the series looks like as shown on the slides as well. So if you want to get the values of the series, you can use this series.values. So let's run this cell, and then you can see it's a array type, NumPy array, and then it has your values. And also we can do .index. So it tells you if the start is 0, stop at 7, but 7 is not included, and the step is 1. So some of you may be interested in about, oh, I don't want the index or label to be default because it's a 0, 1, 2, 3, 4, and so on, doesn't mean anything to you or something. You want to use a custom index. Here, you can use the index equals, you can give it a list. So you can give it A, B, C, D, E, or for example, egg, a cat, a dog, whatever things there. And then the index of this series will be changed. So now let's see A, B, C, D, E. So you can see it's labeled now, it's A, B, C, D, E. So how can we get a value from series? We can use it's integer index or the label. For example, here we use this series square bracket 4, or you can also do the custom label. For example, here we use E, string E. So because it starts from 0, so the integer index from 0 0, 1, 2, 3, 4. So 4 actually is at the same location of E. So we expect this should be true. So because they both go to -5, so get a value from a series. This is how you do that. And if you want to get a multiple values from a series, you can pass in a list. So here for example, I have this series 2. I have A, B, C, D, E, and you can pass in like A, B, C. I just want the first 3 values, and then you can pass A, B, C, and let's run it. And also, you may think, if I want to specify a sequence of these labels, does it change anything? Maybe let's try. So if I do BCA, does it change? Yes, the sequence of the values has been changed. The labels become BCA. And also we can do filtering. For example, you have a series, and for example, you have a stock price series data, and then I said I want to look at the price which is greater than some number, for example, $50 or something, and I want to get the values greater than $50. For here we just use this series greater than 0. So what do you get? Actually, you get another series, but it's a Boolean type. So it has a true or false, true and false. So if you think of this as a mask, but on this mask, you have the true position as a whole. Like you have 3 holes, and these false, you don't have a hole. So if you apply this kind of mask on another same size piece of paper or something, for example, series 2, what you can see? You can see the numbers on these 3 positions, right? So if you just surround this cell, now you can see, you find these values. So this is so-called the filtering or masking. So you can use some comparison operator to filter out some elements, some values. And also you can do scalar operations or math operations ×2. This is very easy. And the data frame is the primary pandas data structure. So here I use a Python dictionary. So you can see it's key value pairs, but the value you can see it's a list. So we have 2 states like Virginia and Maryland, and in different years and what the populations are. And then we pass in this dictionary into and we convert this dictionary into a data frame, and then we got a pandas data frame. So let's see what it looks like. So you can see it's a nicely layout of a kind of like table. You have ordered a collection of columns. So it's the same as the order of the case, state, year, and the population. And also you can specify the sequence of it. If you don't like state, the year, population, you for example, you want to see, I want to put the year first, and then you can, in this column, you give it a list, and you put the year at the beginning, and then you do maybe state or population. It's up to you. And then if you run this code cell, we can see the year now is the first column now. So so if as we said, data frame is a size mutable data structure, and we can add columns. For example, here you want to add you want to include the state and employment rate, but but it don't have currently it don't have one. So you want to see, oh, I want to add an employment rate. Okay, you can give it an employ. Okay, it's a short form, and then, but think about so you haven't given it any data yet, right? So it's just like a not and missing value. So, but you can give it a list, for example, um, give it a list and to fill all these positions. If you find, oh, I found a Virginia in 2012, the employment rate is like a 4.1 or something, you can give it a list and then to get these blanks filled up. And then next we want to tell you how to retrieve a column. Actually, it has two ways to retrieve a column. So you can use a square bracket. So if I wanted to get the state column, I will do square bracket state, and then now you can see you have all the state column extracted. So, and also you can do dot notation by attribute. For example, if I want to get a state, it should give you the same thing. So as we said, the data frame is it depicts a like of a series object. What is its type? So if we do this, should it give us a series? Yes. So it's not. It's correct that a data frame is a dict-alike series object. So it's true. And then we can similarly retrieve a year column, and we can besides the rows, we can also retrieve rows, but we need to use like loc method. For example, here you have a loc. Let's first print out what is df3. I already forgot about it. So we have this data frame, and I want to retrieve the row, first row. I said df3.loc 0, and let's see what we can get. We have the first row. 2012 Virginia population is 5.0, and employment have no data yet because we didn't give the data. Of course, there's another method called iloc. I think it's called iloc. It's an integer location. For example, we also do 0, maybe do 1. So let's see what happens. So we have the year. So if you think, yeah, it's called I is integer location. So it's 1, 2013 Virginia 5.1 missing value. Okay, and this is only for I means integer. So this is only for integer. If you put like a row label, for example, if you have this row label as for example, A, B, C, D, E. If you put A here, string A, it won't give you, it will give you error. And we can also drop entries. We already see df3. So we can drop, for example, drop the first 2 rows. Let's print out. Maybe I don't want the first 2 rows, so I want to drop it. So you pass in, you use the drop keyword, and then you pass in a list 0 and 1, because I want to drop the first 2 rows. What it has. So you can see now we only have the last 3 rows. And you can also drop a column by specifying the access equals 1, because I don't have data for exploration and exploratory rate. Okay. Thank you, Richard, for asking. And so this is you can also drop a column by specify the access to be 1. And if I run this cell, you can see the n-primary column is gone. So we don't have so we can drop the column. And also we can do indexing selecting. This has been we have seen all these cells. So I will just run this one. We can do integer index or label indexing. So we can also do slice. For example, from 1 to 4. Let's check this one. Is 4 included? That's right. So 0, 1, 2, 3. So it only from B to D. So for this slicing, the endpoint is not included. So it only starts from 1, index from 1 to 3. Okay. And you can also specify select specify values from, I think we have done this. And also we have done the filtering. I think I accidentally, okay, do some repeated cells. And then, of course, if you have labels, series labels, you can use the labels to do splicing. For example, A to B. Now you can see actually the output is here. The B is included. If it's an integer index, the endpoint is not inclusive. But if it's a label based, it's inclusive. And also you can assign values to a series slice. So the two values become 0 now, and also we can pass in a list of column labels to get multiple columns. For example, I just want to look at the population in an primary column. And now you can see we have these 2 columns. And get a slice from the data frame. So we can look at it. So you can get the first 2 rows, a slice. And also here we can also do filtering. For example, I want to look at the rows with the population greater than 5 million, for example. It will give you these rows. And also we can do sorting, sorted by index and values. So for example, I want to print out the series 2. And you can see now we changed these 2 numbers. So now it's 0, 0. So if I sort by index, it doesn't change anything. Why? Because the index is already sorted and it's ascending order. So if I use Shift Tab, you can check some things, help card. Do I have ascending? Oh yeah, ascending default is true. So index, sort index, ascending will be A, B, C, D, E. So it's true. And if we sort by values, what will happen? And also we want to use a descending order. So now you can see the values. It's 200, -3, -5. So it's a descending order. So also we can sort index and values on data frames. So for here, I first create a 1D array of from 0 to 11, and then I received it to be 3 rows and 4 columns, and I give it index and column labels. So now it looks like this. So if we want to sort index, it will be alphabetically increasing order. Am I right? O is before T, H is before W. Yeah, it's alphabetically increasing. And also we can do by columns, sort data frame by column. So we just define x is equal 1, and then ascending, because we want a descending order, so we set ascending false. You see that D, C, B, A is descending order, yes. And also we can sort data frame values by column. If you just put a 1, it will just like sort the values of that column. If you have equal numbers, equal values in that column, it will break the tie based on the second column label. So for here, the D ascending order, it's that 3, 4, 3, 7, 11 because we don't have equal values, so the C column doesn't even be used. And also we can data frame. We can read a file into a data frame, and for here we have a read CSV file. And for here I have a CSV file, and I know it's a location because it's in this data folder. So you can read this file into a data frame. So if we run this cell, and then we can have a data frame 1 now, and I want to see what is in data frame 1. So you can see some columns: ozone, solar, wind, maybe temperature, month, day, and all these. It also tells you how many, the number of rows and the number of columns, and you can do a describe. What does describe do? So it tells you the number, the count, how many counts it has. It has so because we have some missing values here, so it doesn't count the missing values. So it has 1116 for the ozone, and 1146 for the solar, and also it tells you the mean value of this column, standard deviation, mean value, max value, and 25, 50%, 70, 75% values. So this is kind of give you information about the data frame. And also you can, if you want, you can use the data frame.add. You can just show the first 5 columns. If you want more, you can, for example, 10. I want to print out the first 10 rows, and also I can do tail. Yes, yeah, we can do tail as well. So we can, if we just want to look at the head or tail, and then you can use the head and tail to look at the part of the data. And the writing, you can just use the data frame to CSV. And I don't want the index, I don't want the header. So if I run this cell, the data frame will be right into a CSV file called ozone-copy. It's in the data folder. So if I go here, okay, you can seconds ago, I have a new file created called ozone-copy. So it's here. Now you have this data frame 1 written into this file. Okay, I will also continue to talk about the matplotlib, so I will give you some time to look at all these examples. You can, for example, you can, you want to test on something, you can click this plus sign and add some code cells, and then you can type some code into it. And if you, you can explore what you want for the data frame, the pandas. And also for Matplotlib, it is a Python library for plotting, as we said. So it has two concepts, key concepts. One is called the figure, the other is called axis. So figure is the object that keeps the whole image output. Like you can imagine it as a figure canvas, and you can adjust the image size, and also you can use tight layout. Sometimes when you do, for example, subplot, you have a multiple plots, subplots on the figure. Sometimes they can be overlapped, and it's not so nice. And if you use the tight layout, sometimes it can give you maybe it use some padding or something, and then it makes the layout much better. And also axis is an object include a pair of axes. So you can set the X lane from like a number to another, and then set a Y lane, arrange, and then set an X label, Y label, and plot title. So you can set all these things for the figure. This is the same thing for all this picture, and you can see all these things. So let's look at the figure, how to plot the figure. And then first we create some data. So X from 0 to 5, we have the 10 points, and I want to calculate Y equals X to the power of 2. And then I create a figure instance, use the plot, because first we need to import, where's my import? Okay, here, import a matplotlib.pyplot as PLT. You can see if you use some alias, or you can call it a nickname, and it'll be easier for your code writing. You can just use the PLT to represent this long name. And then you create a figure instance called a fig, and also you can use the add axis. So you have an axis object. And then actually this axis is the real plot that you plot the data X, Y, and you give it red color. As we said, we can set the X label, Y label, and the title. So if one of these cell, is it right? Is it a red line? So we have kind of like power order of 2 red line. And also you can do subplot. If you do not plot dot subplot, if you do not specify any like arguments in the parentheses, for example, here, if I use shift tab, it should have a number of rows, number of columns. But if you do not specify it, the default has a 1 by 1 plot. So it's a 1 by 1 plot, it's 1 plot. So if we do this, it's the same thing. And also we can use these, we can do multiple subplots. We can specify the number of rows, number of columns, and this should be 1 row, 2 columns. So do like this way. Okay, and I will continue. So I think we just have 1 hour now. So, so we have some. We can also do color map, 2D color map. So for example, we have a function that is maybe a physics function about the qubit potential something. And we have some angles like phi m and phi p. And if we run this function and we generate some data points of angles, and it has 100 phi m and 100 phi p. And we do a mesh grid, so it can be a 2D mesh grid now. And then we put these to x and y, we will be able, and in this function, we will be able to calculate the values of each grid point into z. So, and also we have a transpose dot t here. So if we use, we can do color plotting, we can use the two different methods here. I show the first one is called a p-color. You can use axis.pcolor, and you have some parameters x, y, and z, and it kind of normalize x, y, and z. So it's from 0 to 1. If we run it, just shading all flat. Okay, you can see this figure now. So it's a nice 2D plot. Similar thing to image show, it only asks for about the z, the function value, and also use the interpolation bilinear. We have a color bar. So on this one is the same thing. Yes. So we can use the we can do 2D color plot, use the p-color and the image show. So if you there are some contour plots. Some students may think it's useful because it's kind of like if you learn about like basic geology or something. If you do some like contour lines, means the on this line it has equal elevation, but here means on this line we have equal numbers. So it can give you kind of what is called contour line, and each contour line has the same number of numbers of the same values. And also we can do 3D figures. So first we need to import our Axis 3D. And at 0, we do create a figure instance, and then we add a subplot. It's 1 row, 2 columns, the first position. Project, we specify this keyword argument projection to be 3D. We will get a 3D figure. So we have another one. Actually, the data are the same, but they have some other parameters are not the same, like a row stride and a column stride. So let's see what we have. Okay, and you can see it's the same data, but the stride on this surface are not the same. So you can do 2D, and also you can do color bar. You can shrink it, because sometimes if you do not shrink it, it could be very large. Yeah, it could be very large. If we can shrink it to be half of the original size, this is almost about the same as the figure size. So it's nicer. So I encourage you, because there are a lot of parameters arguments in these things. So I encourage you guys to look at these arguments in your spare time after class. And also we can wireframe plots. Also we specify a keyword argument projection to be 3D. So we can be able to do a 3D wireframe plot. So we use the same data, so you don't have to worry about the data if it looks different or something. So you can see now from this plot, we can have a wireframe plot. I'm not quite sure the use of this wireframe plot. Maybe some students in different majors, they may think it's useful. This is useful. And also we can do contour plots with projections. So let's see how it looks like. And this is our like a projection of this figure onto different directions. So this is give you a different view, like a top view, side view, to side views. So this is also, I can imagine the use of this figure in geology, because sometimes we do projections of the stuff onto horizon of surface, and then we do some analysis. And here it's kind of an application of this plot. And here I have some case studies. You can look at all these examples and exercises. I even have some exercises. You can look at all these examples and exercises to write some code, and you will be able to remember it more clearly. Okay, this is not a code cell. And I will give you like maybe 10 to 15 minutes to work on this. After that, we will continue. So I will create the breakout room. I will open the breakout room. So you please please accept the invite and work in the breakout rooms. So I will click the open all rooms now. Sorry, I forgot to unmute myself. I was unmuted.
General,
came
I'm
back
trying to help a couple of students who are
Yes,
not yet
thank you.
able to do this. Can you please put
Uh-huh.
me in the room with those students?
So how was how was their situation now? So they have a file quota, is like a problem.
Something like that.
Okay.
I need to be in the room with those students.
Oh, these two students, Divya and Milad. Thank you, Richard, for providing another solution for them to create a virtual environment.
Genoa, are you going to put me in a room with those two students? I am not a
Sorry,
host. I cannot do it.
I just realized this. Divya in room 1. Oh, let me put you room 1. Okay, can you guys hear me now? Okay, great. Now let's continue and finishing the data exploration part. We want to continue with machine learning, and in this machine learning is kind of like you use some data set as for example training data, and you train your model, and so the model can automatically improve from by using this data, and then it can be used to make predictions. So in machine learning, actually we have different problems, different tasks, or you can see on this figure, we can have like 4 different islands, if you want to call it islands, and we have a classification problem, we can have regression, class sharing, and a dimensionality reduction. And these are the common problems in machine learning. And this is scikit-learn gives you a idea like if you follow a path, you will be able to land on a island. So you will be able to identify, okay, my problem is that, for example, a classification problem, or your problem is maybe if you do like this, your path is like this, your problem may be a regression problem. So this is for this path is not necessarily true, because for example here it has says if you have more than 50 samples, you can do like a category or stuff, but actually it really depends on your project. If your project needs a lot of data, 50 samples may not be enough. So you may want to you may want based on your own project, you may want to decide these numbers. So more data, or either define whether it's about a category or stuff. So the main features of the machine learning library scikit-learn includes like different features like classification. It seeks to identify which category an object belongs to. For example, you have a spam detection, like the spam email or not, image recognition, cat or dog, or something like that. And also you can do regression. Regression is seeks to predict continued valued attribute. Like for example, you want to predict the price of a house based on some of its attributes. For example, it's a living area, or the living area size, or number of bedrooms, or is it has a waterfront or not. So you can predict the house price, and then this is a regression problem. And also in clustering is like you have a set of data points, and you want to group these data points into like several different groups. And in each group, the data points are more similar than the data points outside of this group. So this is kind of clustering. And we also have other dimensionality reduction, model selection, pre-processing. They are also features of scikit-learn. And I want you to, based on the time, I want you guys to look at all these different features about scikit-learn. Let's go back to the Jupyter Notebook, so I can look at the machine learning Jupyter Notebook. Okay. So this is what we just talked, and then first we need to import. Let me clear all the output. So first, let's do why this is here. Do not want it. Do not want this here. Okay. So for example, here we need to import the libraries we need. We want to do some plotting, so we still import the matplotlib, and also we import the NumPy as well. We use some here you can see we use NumPy length space to create some data points. And so here we use a machine learning model called linear regression. So we want to do a linear regression from scikit-learn linear model. We import the linear regression. So if I run this cell, hopefully my Jupyter Notebook is still working. So it has to use some of your patience. So the second cell means like generate a data set, and linear regression is fit a linear model with coefficient to minimize the residue sum of squares between observed target and the prediction target. So so let's see the data points. So we have 20 data points, and we add a new axis, so it will be 20 by 1. So this will be a 2D array after we add a new axis. And then we have some, we also create a Y based on X, and also we add some randomness. So the data points would be, have some randomness. And we plot figure and plot these X, Y to look at how these data points look like. So you can see it's like this. So it has some randomness, and we want to feed a linear model into the data. So how do we do that? And we can check the shape of the data, use the dot shape, and then we create an instance of the linear regression model. And after we have this model instance and we feed the data points into this model, meaning like we feed the model into these data points, and then the model started to learn and improve itself based on this training data. And it will learn something. What is its knowledge? Like for a linear model, like if you do like y equals AX plus B, the model's knowledge is based on the coefficient, right? The A and B. So let's see if we feed X, Y to the model, and then what does it learn? Does it learn a coefficient and intercept? Let's see. Yes, it learns a coefficient and also an intercept. So the model learns about something. So now it's a trained model. It's a trained model. So let's see a score of how it's good. It's about 98%. That's good. And also the model has been trained, and it can be used to make predictions. So you can pass some data into the model, and you ask them to tell you its prediction. So for this one, we use the trained model dot predict method. When you train, you use the dot fit method. So now we do, and also if you want to do the score, how good your model is, you can, for this one, you can use model.score. And we predict, and then we plot the best fit line from the model. And also we plot a scatter plot of the original data, so to see how close they are. So now you can see this model makes a pretty good prediction, and it's very close to the data points. And so we can see it's very good. And also we can do polynomial feeding, like not just fitting a straight line. We can use the polynomial curves. Now we have the data points X the same as the above, but now we generate a Y, and now you can see we have some polynomial term in it. And also we have some randomness. So we have new data sets, but the Y has been some of a polynomial, has some polynomial term of the X. And how we do that? And we horizontal stack these X, the polynomial terms. And then because this model, we have this model, but we want it to learn from a new data set. So we use X polynomial and a Y, and let the model to learn, give you this data, and it learns. And then we want it to make some predictions, right? So after it makes some predictions, and also we want to plot these data points and the prediction, to see how they are close to each other. So now you can see we do a polynomial fitting. It's very close to the data point, so it's pretty good. And also you can check the data shape by using dot shape. And also you can use some help and to look at the horizontal stack. So, okay, this is about regression. And also we, in the machine learning, another problem is about classification to seek to find which category the object belongs to. And also you need a training data set, and also in the training data set, this data set has a label, meaning which category, which class it belongs to. You know this. So we have different algorithms. Here we have a support vector machine and algorithm. So it can be used for either classification or regression as well. And it seeks to find a vector, or for example, if you can find a line or hyperplane like in multi-dimensional space. So it is separate the different classes. So here first, we want to use the scikit-learn data set, make blobs to make some clusters, and then we want to SVM to do some classification of these data points. So we use make blobs, and we have 500 points, sorry. And we have two clusters, and we have some random state, and also cluster standard deviation. It's how distributed the cluster. So so let's see what kind of clusters it generates. So it's look like this, and you can see we have two clusters, and maybe if we want to put a line, we want to put a line from here. And now let's create an instance of a support vector classifier model, and we want to use linear kernel. And we fit the data we generated into the model, like give the data to the model and then let it learn. So can it learn something? Let's see. Can it give also this model? It has some attributes like a coefficient and intercept. It also lets you to plot the line. So you can look at this after class, and we can plot the specific line, and also the coefficient is also there. And let's see if it's a line from here. So you can see actually it's separate these two classes very well. And so this line is a good boundary between these two clusters. And also we have KN classifier. So the full name is for KN is the K nearest neighbors. So also it can be used for classification or regression. The input will consist of K closest training examples in the feature space. And if you are given a new observation, you want to look at the points that are closest to it, and then assign the predominant class. So this is K, and K means how many neighbors. So we use the make blobs. This time we make 4 clusters, and I give them some color. So let's see how these clusters. So we have 4 clusters, and now we create an instance of the model neighbors, k-neighbor classifier, and we want to the number of neighbors to be 4, and we want to use uniform weight. We don't want to distinguish them. So we create a KN model. This model hasn't learned anything yet. So we give, by using fit function, we give all the data to this KN model so it can learn. So let's run this cell, and then this model, now it has some data. It learned from this data, and it can make predictions. So for here, you can see we have 4 clusters, and I wanted to predict x equals 1, y equals 6. I want to predict a point at about this location. So what a class it is. So let's run this one and then see what the color it is. So it's a green color. So it means it has been classified as this class. So you can see actually it's very close to this cluster. So it should be a green class. And also in machine learning, we have clustering as mean we group data sets, group data points into different data into different groups. So it's all based on the similarity and the dissimilarity. So for here we use let's first plot the data again, and then we use k-means. K-means k-means is searches for I mean like searches for the centroids of clusters. So the centers. So for example, we have all these clusters, and we know its centers. So we know its centers. We use k-means and a fit, and then we have some predictions, and we can use its cluster centers attribute to print out the centers of these 4 clusters. So if but now if you are just given these numbers, so we can plot these points back on the figure to see if the centroids seems okay or bad or something. So let's plot them back. So you can see, why it has, okay, it's not the same cluster with this one, because you can see here, my cluster, the cluster standard deviation, I changed it to be 1.0. So you can see the clusters are a little more difficult to separate, but still, you can see the class centers are very, I think they are very good. So this is about clustering, and also we can predict the clustering. So this is about thing. Okay, and then the next is about some additional materials about the principal component analysis. So it's about like a dimensionality reduction. I want to talk about this. I want to leave it to you guys to look at the last one, additional material principal component analysis, in your spare time. So let's go to the deep learning notebook. So for deep learning is actually a subset of machine learning. So it's just used like a deep neural networks, like to mimic like the human neural system. So it has like a layers of neural networks. So and it can be divided in supervised learning and supervised learning, reinforcement learning. So for in supervised learning, actually you train the model with the labeled data. So it means like, for example, you have an image, then on the image it's a cat, so you have its label, and also and it's included in the regression and classification problem. For unsupervised learning, it doesn't, the training data doesn't have a label. For example, you have some dinosaur data, but you don't know what type of dinosaur, what types of the dinosaurs are, but you only know about their head size or and a tail size, but you want to put all these data and you want to group them to see if they are similar. So, but you don't know what it is. So this is just a kind of clustering, but you don't have the labels for the data. Reinforcement learning is kind of about, for example, it's about like a reward or something, like a intelligent agent, for example, in an environment, it do some actions and then get a reward, and it try to maximize its reward. It has no training data. So it is used in robotics and self-driving cars. If you are interested in reinforcement learning, you can learn something online, or I think even there are some courses on about the reinforcement learning. So I think I don't have time to talk about the machine learning, the difference between traditional learning and machine learning. So machine learning is not about a physics equation. For example, in traditional modeling, for example, I did like a geomechanics modeling before, and I start with the equation of motion. So this is a kind of like physics equation, and then I learned some numerical method for finite element method, and then discretize the model, and then I have some like initial conditions and boundary conditions, and then by calculation I can calculate some stress, for example, somewhere in the model. That's what I did in my geomechanics study. But in machine learning, it's not like this. It's kind of like, for example, you have a neural network here, and you have some input and output. So this kind of a mapping function from the input to output. You have some data, and you know the output, and then you, by using the computer, you train your model. And then when you have some new data, you let the model to make predictions through computer. So this is the difference between traditional modeling and machine learning modeling. In deep learning, we are planning to use Keras, and this is a workflow for Keras. So here we will import some libraries as usual. So this is about the linear regression. And linear regression with the scikit-learn, we have learned about it. I will clear all the output. This is very sad. So again, I just clear it. So we imported the package, and then we generate some data points and add some randomness. And then we plot these data. And if we use the scikit-learn, we just talked about it. So let's see, the model learned about the data. So we have a linear regression model, and we train the model, and then we make predictions with the model. So actually, for deep neural network, it can also do linear regression, and we can use a method called a sequential library. And in this sequential means like if you want to build up a neural network, you want to build it sequentially, like a layer by layer. So for here, you have a sequential, you have a dense layer, like a regular layer of neural network. And units means the dimensionality of the output. And also you have an input. This will generate an input layer. So you have one and you have one. So here in the model, we need to specify its loss. What if loss you want to use the error, mean squared error we want to use. Like, and also we want to use a gradient descent to be the optimizer. And then we compile this model, and then again, we train this model by using fit function. And we want to iterate the data set 500 times, it means the epochs. So if we do this,
Can you like the optimizer you chose gradient descent? You could use OLS too, right? You just chose your gradient descent.
yeah. So let it run. And also we can use model predictor to predict the data. So it takes a few seconds. Okay, now it's good. And then we have a trained model now. We use the predict to get the predictions. We can plot them out. So you can see actually by using Keras deep neural networks, we can also do linear regression. So not necessarily like a machine learning linear regression. You can use the deep neural networks to do linear regression. So the last one is about a handwritten digit classifier. So use Keras. And at first, we need to have our data. So our data is from MNIST data set. So it's from a Keras data set. We imported MNIST. So first we will need to have all these libraries in our session, and then we call load data to load all these data, and also these split the data into train and test. So if we split these data and into training data set and test data set, how many of the so let's think how many training sample we have. So we have about 60,000 images, 28 by 28 images, and also about how about the test? So it's about 10,000. So it's about a 6 to 1. That's okay. Yeah. And then again, we will be we want to do some data visualization to see how these images look like. So we use matplotlib plot.figure, create a figure instance, and then we want to plot the 15 figures. So let's see these how these figures look like. So you can see we have these 15 figures, and also the labels are printed out. So, and then we use the training data set to train our model. So now we don't have our, also we need to normalize the training data set. We can just call utils normalize training and test data set. And okay, we have a shape here. Then we can build our model by using Keras sequential class. And then in this Keras sequential class, we can, at the beginning, you can just add these layers into these appendices, but also you can use add method to add layers by layers. So first we flatten the input layer, and then we do a 128 like neurons, and then use ReLU activation. The next layer is also 128, and then upper layer has 10 numbers. It uses softmax, and it will give you the possibility of being these the 0 through 9. So it will tell you what number it is based on the probability. So again, we will specify the loss function and the optimizer. The metrics, we use the accuracy. So you use the model compile this model. This is about TensorBoard. We will not talk about it. So now we train this model by feeding the data into the model. So we have one epoch. So let's see the model summary. So you can see the layers and also the number of parameters it has. So this is about our model. And then we can, by using model evaluate, we can output the accuracy of the model, how good it is. So it's about 95.4%. So it's good. If you want to save your model, you can use model.sieve. So you can use it somewhere. You can use it for other project, and you can just load the model back. So you can use the model.load model, and it loads the model back. And then we can do model prediction, model predict. So here's a function about to plot a single image. It uses image show, as we have talked about in the data exploration matplotlib. We use the image show, and for this one, and we run this function, and then we want to find out which image is not predicted correctly. So let's see. So you can see this label says this number is 5, but our trained model says it is 6. So actually, this number to me, it looks a little bit like 6, and also looks like 5. So this could be very confused, and then the model could make a mistake on the figure. So I think it's good. And sorry guys, we passed 6 minutes. Hope you guys, I know some of you guys may still have a problem about creating virtual environment, but all the notebooks have been given to you, and you can get clone from my GitHub and continue to work on all these, look at these examples. So hopefully you know how to use our Open On Demand portal to use our HPLC clusters and also run some works on it. Okay, that's all for today. Thank you guys for attending this short course. Hopefully to see you guys in the future short courses in HPLC.